I take this result in many of my problem solving sessions, and often students ask that how do you say a cos theta plus b sin theta always lies between minus under root a square plus b square and plus under root a square plus b square. So I just thought of making one short on this, and I will prove this result for you here. Now let me take that a cos theta plus b sin theta is y, and I multiply and divide by under root a square plus b square. Now these quantities a upon under root a square plus b square and b upon under root a square plus b square, which we are seeing inside the bracket, they are important to us. Now why do I say so? Just see this. A square plus b square is greater or equal to a square. I divide by a square plus b square on both sides, and that leads to a square upon a square plus b square less or equal to 1. You know this is of the form x square less or equal to a square, and you know how to write solutions of such inequations. And that would lead to a upon under root a square plus b square that lies between -1 and 1. And now since we have seen that a upon under root a square plus b square lies between -1 and 1, this is going to help us in our next steps. Now I take cos t as a upon under root a square plus b square. Why do I say so? Because just now we have seen a upon under root a square plus b square lies between -1 and 1. And that actually gives me sin t as b upon under root a square plus b square. And by taking these two quantities as cos t and sin t, actually y's expression gets simplified to under root a square plus b square into cos t cos theta plus sin t sin theta. And we know cos a cos b plus sin a sin b is cos a minus b. Using this formula, I write y as under root a square plus b square into cos t minus theta. Now what about cos t minus theta? That always lies between -1 and 1, and hence this leads to y lies between minus under root a square plus b square and plus under root a square plus b square. And what was y? Substitute that back, and that gives me a cos theta plus b sin theta always lies between minus under root a square plus b square and plus under root a square plus b square, and this completes our proof.